3 minutes ago, astronomers monitoring data from the James Webb Space Telescope noticed something that should not be happening. Two planets, hundreds of light years apart, both caught in the middle of a violent transformation. One is slowly bleeding its own atmosphere into space. The other is being torn apart by heat so extreme that scientists say it rains liquid rock. This is not a simulation. This is not a theory. This is happening right now, captured in real infrared light by the most powerful telescope humanity has ever built. And the more scientists study it, the more terrifying it becomes. Stay with us, because by the end of this video, you are going to understand exactly why researchers are calling this one of the strangest planetary events ever observed. The James Webb Space Telescope was launched with one mission in mind: to see things no other instrument could ever hope to see. It orbits the Sun nearly 1 million miles from Earth, far enough away that its instruments stay perfectly cold, perfectly sensitive, perfectly capable of detecting the faintest whispers of infrared light traveling across the galaxy. And recently, 2 of those whispers led scientists straight into one of the most dramatic planetary discoveries of the year. Let's start with the first planet. Its name is WASP 107b, and it is what astronomers call a super puff. Imagine a planet roughly the size of Jupiter, but with a fraction of its mass, so light and so loosely held together that its outer layers barely cling to the planet at all. When Webb turned its instruments toward this strange world, it detected something astonishing: massive streams of helium gas pouring off the planet and escaping directly into space. Not a slow, gentle leak. A dramatic, continuous outflow, like the planet is exhaling its own atmosphere into the void around it. Picture that for a moment. An entire world slowly unraveling itself, atom by atom, losing pieces of its own identity every single second, carried away by the relentless radiation of its host star. Scientists studying the data describe the planet as having an enormously inflated, weakly bound atmosphere, one that simply cannot hold on the way a planet like Earth can. Over enough time, this kind of process can completely reshape a planet, stripping away its outer layers and leaving behind something smaller, denser, and almost unrecognizable compared to what it once was. This is not the first time scientists have seen atmospheric escape happening on a distant world. But the scale of what Webb detected on WASP 107b is something else entirely. The helium signal was strong enough and clear enough that researchers could actually measure the outflow directly, giving them one of the best real-time views ever captured of a planet in the process of losing itself. Some scientists believe worlds like this may represent an entire missing category of planets, ones that formed as bloated gas giants but are destined to slowly transform into something completely different over millions of years. If you think that discovery is unsettling, wait until you hear about the second planet, because this one might be even stranger. Its name is WASP 121b, and it is often described by astronomers using a single word: extreme. This planet orbits so close to its star that one full year, one complete trip around its sun, takes less than a single Earth day. It is what scientists call tidally locked, meaning one side of the planet always faces its star in permanent, blistering daylight, while the other side remains locked in eternal darkness. When Webb studied this planet using a brand new observation technique, tracking the planet's rotation to separately analyze its morning and evening regions, the results were almost impossible to believe. The day side of this planet reaches temperatures near 2,700 degrees Kelvin. That is hot enough to vaporize metal, hot enough to break apart water molecules before they can even form a stable signal. Meanwhile, the night side, still incredibly hot by any human standard, sits over 1,000 degrees cooler, creating one of the most extreme temperature contrasts ever measured on a single planet. But temperature alone is not what makes this planet so disturbing. Scientists studying WASP 121b believe that on this world, it can actually rain liquid rock. As blisteringly hot gas rich in vaporized minerals moves from the day side toward the cooler night side, it begins to cool and condense, potentially falling from the sky as molten droplets, the same way water condenses and falls as rain here on Earth, except on this planet, the rain is made of vaporized stone. Try to imagine standing on a world where storms do not bring water. They bring liquid minerals falling from a glowing, superheated sky. If your mind is not already blown by that, take a second, because we are just getting started. And if you are enjoying this deep dive into the most extreme planets ever discovered, go ahead and hit that subscribe button, because Webb has plenty more terrifying discoveries waiting to be uncovered. What makes WASP 121b even more fascinating is how Webb managed to study it in the first place. Instead of relying on a single averaged reading of the planet's atmosphere, researchers used the planet's own rotation to their advantage, carefully separating light coming from its morning edge and its evening edge. This allowed them to build, for the first time, a detailed picture of how heat and chemistry shift across a tidally locked world in real time. What they found was a level of atmospheric asymmetry stronger than any computer model had predicted, forcing scientists to rethink some of their basic assumptions about how these extreme planets actually behave. Both of these discoveries point toward a much bigger truth about our universe, one that is honestly a little humbling. Planets are not static objects, frozen in place, unchanging for billions of years. They are dynamic, evolving, sometimes violently transforming worlds, shaped by forces so extreme that nothing in our solar system can fully prepare us for what is out there. A planet can lose its atmosphere entirely. A planet can experience storms made of vaporized rock. A planet can exist in a state of permanent, brutal contrast between fire and darkness, all at the same time, on the very same world. For scientists, discoveries like these are not just fascinating, they are incredibly valuable. Every observation of a planet undergoing extreme transformation helps researchers understand the life cycle of planets across the galaxy, including, in some strange way, our own solar system's distant past and future. Studying how an atmosphere escapes a planet like WSP 107b, for example, gives scientists crucial data about atmospheric loss in general, a process that may have shaped the early history of planets much closer to home, including potentially even Mars, which lost most of its own atmosphere billions of years ago. And studying a planet like WSP 121b with its extreme heat and violent chemistry helps astronomers understand the absolute upper limits of what a planet's atmosphere can endure before it begins to break down entirely. These are not just curiosities floating in some distant corner of the galaxy. They are natural laboratories, extreme environments that let scientists test their theories about planetary physics in conditions that could never be replicated here on Earth. What is perhaps most incredible about all of this is the sheer distance involved. WSP 107b sits roughly 200 light-years away. WSP 121b lies even farther, drifting through space in a completely different direction. Yet Webb, sitting quietly at its observation point nearly 1 million miles from Earth, was able to detect helium escaping from one world and separate the morning. Light from the evening light on another, all using nothing but the faint infrared glow these planets emit into the darkness of space. That level of precision would have sounded like pure fantasy just a decade ago. It also raises an important question that scientists are only beginning to explore. If planets this extreme, this violent, this transformative exist in such large numbers across the galaxy, what does that say about the planets we have not found yet? What other transformations are happening right now at this very moment on worlds so far away that their light has not even reached us? Every single discovery like this expands our understanding just a little further, revealing a universe that is far stranger, far more dynamic, and far more dangerous than most of us ever imagined growing up looking at simple, static pictures of planets in a textbook. Researchers are already planning follow-up observations for both of these worlds, hoping to track exactly how quickly WSP 107b continues to lose its atmosphere, and how consistent the extreme asymmetry on WSP 121b remains over time. Some scientists believe that continued monitoring could eventually allow them to build detailed models predicting exactly how planets like these will look decades or even centuries from now, giving humanity an almost unprecedented window into the long-term evolution of alien worlds. Before we wrap up, it is worth remembering just how young this entire field of study still is. Telescopes capable of this kind of precise atmospheric analysis have only existed for a few short years. Every single observation Webb makes has the potential to overturn assumptions that have existed in astronomy for decades. The two discoveries we just walked through are proof of exactly that. Scientists expected planets to behave in relatively predictable ways. Instead, they are watching entire worlds transform in real time, right in front of their instruments, in ways that challenge nearly everything we thought we understood about how planets survive or fail to survive, the environments around their host stars. So, the next time you look up at the night sky, remember that somewhere out there, invisible to your eyes, but perfectly visible to Webb, there are planets actively unraveling, planets raining liquid stone, and entire worlds slowly transforming into something new. The universe is not sitting still, and thanks to the James Webb Space Telescope, we finally have a front row seat to watch it happen. Let's go a little deeper into just how strange a planet like WSP 107b really is, because the numbers involved are almost impossible to picture. This planet has roughly the same width as Jupiter, one of the largest planets in our own solar system. Yet its mass is only a tiny fraction of Jupiter's, meaning the material that makes up this planet is spread incredibly thin. Scientists sometimes compare its density to something closer to cotton candy than solid rock or metal. That low density is exactly why its atmosphere is so loosely held in place, and exactly why powerful stellar radiation is able to strip away helium gas so easily. sending it streaming off into space in massive visible plumes. What is even more remarkable is that Webb was not just able to detect that this escape was happening. It was able to measure it with incredible precision, tracking the speed and direction of the escaping gas as it moved away from the planet. This gave scientists a genuine real-time view of a planet actively losing part of itself, something that used to only exist as a theoretical concept in computer models. Now it is something researchers can actually observe, measure, and study, almost like watching a slow-motion video of a planet's atmosphere unraveling thread by thread. Some astronomers believe that planets like WASP 107b may eventually evolve into an entirely different category of world altogether. If the atmospheric loss continues at a significant pace over millions of years, the planet could gradually shrink down, losing its puffy outer layers and leaving behind a smaller, denser core. In other words, this planet may not stay the way it looks today. It could be caught in the middle of an entire life stage transition, evolving from a bloated gas giant into something astronomers have never directly observed before. Watching that transformation unfold, even in small increments, is exactly the kind of discovery that keeps scientists coming back to this planet again and again. Now, let's return to WASP 121b, because there is another detail about this planet that makes it even more unsettling once you understand it fully. Because the planet is tidally locked. Its day side never experiences night, and its night side never experiences day. This means the extreme heat on one side is not a temporary event. It is permanent, forever. For as long as this planet exists in its current orbit, one half will remain locked in scorching daylight while the other half remains locked in freezing darkness by comparison. There is no sunset. There is no sunrise. There is only an eternal, unmoving boundary between fire and shadow, a boundary scientists call the Terminator. And it is exactly that boundary Webb focused its instruments on to capture this discovery. Studying that Terminator region gave researchers something they had never fully captured before, a detailed look at how a planet's atmosphere behaves as it moves between two impossibly different environments. On the morning side, temperatures are slightly cooler and evidence suggests that vaporized minerals may be condensing there, potentially forming clouds or even that strange mineral rain we talked about earlier. On the evening side, after gas has been superheated and swept across the day side, temperatures spike even further, and water molecules become so energized that they essentially break apart before they can leave a clear signal in the data. That difference alone forced scientists to completely rebuild the models they had been using to understand this planet because the old assumptions simply could not explain what Webb was seeing. Both of these worlds remind us just how limited our imagination can be when it comes to what a planet is actually capable of. Growing up, most of us learned about planets as simple, fixed objects. Rocky ones, gas ones, some close to their star, some far away. But always static, always predictable. WASP 107b and WASP 121b completely shatter that idea. One is a planet quite literally leaking itself into space. The other is a planet permanently split between apocalyptic heat and freezing darkness, complete with skies capable of raining liquid rock. These are not distant, abstract concepts anymore. They are real, measured, documented observations, coming directly from one of the most advanced scientific instruments ever built by human hands. As Webb continues its mission, astronomers expect even more of these extreme, transformative worlds to be uncovered. Each new discovery adds another piece to an increasingly complex and fascinating puzzle, one that is slowly rewriting our understanding of how planets form, evolve, survive, and sometimes, ultimately, come apart. And every single time scientists think they finally understand the boundaries of what a planet can be, Webb seems to find something new that pushes those boundaries even further. If you want to keep exploring the most extreme and terrifying discoveries the universe has to offer, make sure you are subscribed because Webb is watching, and we will be right here to bring you every single discovery the moment it happens.